All right, example 5, evaluate the limit if it exists. Now, we talked about yesterday some indeterminate forms. 0 divided by 0 is an indeterminate form. Another indeterminate form we could get is infinity minus infinity. That's what's going to happen on this one. Infinity minus infinity, because I don't know how big infinity is. If this infinity is exactly 2 bigger than that infinity, the answer to that is 2. So if this infinity is exactly 2 less than that infinity, the answer is negative 2. So infinity is not a definite spot, a point. So the bigness of infinity is different. All right. This infinity can be so much bigger than that infinity, the answer is still infinity. So again, it's indeterminate because I can't figure out what it is by looking at it in infinity world. The way I see this happening here is if I substitute 1 into this expression, 1 over x minus 1, I'm going to get 1 over 0, which is infinity. You take any number divided by 0, as you get closer and closer and closer to 0 on the bottom, you're either going to be going up to positive infinity or down to negative infinity. Just in general, we call that infinity because we can do some algebraic stuff to it to get a better clue as to what this is. The same thing here, if I substitute 1 into this expression, we get 2 over 0, which is infinity. They're being subtracted, so infinity minus infinity is our indeterminate form happening on this one. All right. And again, that's your first priority on a limit problem. When you see LIM, stick the number in and see what happens. Yeah. If you stick the number in, you get 7, you're done. All right, and the answer is 7. But if you get the answer 0 over 0, indeterminate, infinity minus infinity, indeterminate, now you got to start modifying the equation. Most of the problems that you see at this point will be that type. There will be an occasional one where just sticking the number in works, just to make it worth your while to do it. Okay, but occasionally it'll work. Now, what I want to do here is if I get an infinity minus infinity situation, I want to see if there's a way to combine the two pieces together to make one piece. So I get better, the 0 over 0 is a better structure than infinity over infinity. Okay, I just prefer that structure. So what I would do here, since I have a fraction minus a fraction, is I would probably get a common denominator, add the fractions together. That's what my plan would be on this one. So if I come over here, limit as x approaches 1, this first fraction, instead of 1 over x minus 1, I'm going to multiply top and bottom by x plus 1, because I recognize x minus 1 times x plus 1 is the factored form of x squared minus 1. So I'm creating that common denominator for the two fractions. I'm going to leave the second fraction as is, it already has the denominator I want. I'm going to leave it at x squared minus 1 just with the knowledge, that x squared minus 1 is equivalent to x minus 1 times x plus 1. So then if I add the two fractions together, now that they have a common denominator, again, this object equals that object, so the denominators are equal. I simply have to do x plus 1 minus 2 on top. So I end up with limit as x approaches 1 of x minus 1 on top. Now, I've got either x minus 1 times x plus 1 structure or x squared minus 1. Which one do you think would be the better structure to write down? X. Yeah. And this one right here would be the better one to write down, because if we put 1 into this, it makes 0 for that, it makes 2 for that, right? And 0 on the bottom is the problem. So by keeping them separate, that blue expression, x minus 1, is the issue that we have to make go away. The x plus 1 is fine, it can stay where it's at. So I'm going to put x minus 1 here times x plus 1. So if you have a choice between factored or not factored for these structures, typically factored is the better, because again our goal is to factor and then cancel common factors. And what you should notice here is the x minus 1 on top matches this x minus 1 on the bottom. Those cancel, leave me with 1 on top. And at this point, we have limit as x approaches 1 of 1 over x plus 1. Once again, I've got a structure. I've got a limit as x approaches a number. I let the number replace x, 1/2, and we end up with 1/2 as the answer to that. Which tells me that this infinity is exactly 1/2 bigger than that infinity. Again, I can't do that or know that until I actually go through the algebraic simplification process to figure out that information. So you want to get rid of what's causing 0 on the bottom, and that's how you do it.